assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Given this reaction between a hydroxyl radical and a chlorofluorocarbon, use bonded energies to explain why this reaction is improbable. If we draw in all of the bonds explicitly, on the left-hand side, we have an OH bond, two CF bonds, two CCl bonds, and on the right, we will have an HO bond, an OF bond, a CF bond, and two CCl bonds. What happens here is that this fluorine, or that fluorine, moves and bonds with this hydroxyl radical. And so what we need to talk about is the energy of breaking this CF bond and forming this OF bond. And if we look up in a table what those energies are, CF is 485 kilojoules per mole, and OF is 190 kilojoules per mole, where this is the energy released by breaking this bond, and this is the energy that we need to form this bond. And so if the total delta H of reaction equals the sum of the bonds broken and the bonds formed, then what we need to take into account is that this will be a negative number because we need this amount of energy. So the total delta H will be 485 minus 190, which will be 285 kilojoules per mole. Now I'm going to start a new page, and we're going to look at this. Since we found that delta H is 285 kilojoules per mole, this means that it's greater than 0. Since delta H is greater than 0, you can think of this as gaining energy or gaining heat. This means endothermic. If the reaction was exothermic, it would probably happen and it would give off some heat. But since the reaction is endothermic, it needs energy. And because it needs energy, it's most likely improbable, especially since this question deals with the atmosphere. If you look at chemicals in the atmosphere and they need energy, most likely the reaction is improbable.